Hello, everyone. Our next lesson is on how mountains affect climate. And I don't mean being on top of a mountain, the presence of a mountain range. Okay, so this is what is known as the orographic effect. That prefix oro refers to mountains. Later in the year, we're going to learn that the process of mountain building is called orogeny. So that ORO prefix usually refers to mountains in some way, shape, or form. Okay, now a couple of preliminary concepts to kind of review back on. First thing, like what I have underneath the heading here. Rising air makes what? What does rising air cause to form? This is a little bit of review. So what do you think? Think about it. Well, the answer is rising air makes clouds. And if you remember, you're experts on how clouds form. Rise, expand, cool, condense. So as a basic rule, you're going to have rainy zones on Earth anywhere the air is rising. And you're going to have dry, sunny areas on Earth anywhere the air is sinking. That's a basic rule to remember. Okay, so what it comes down to is what things make air rise. Well, one thing that makes air rise is mountain ranges. Now, if you look at your diagram, I have an arrow here, which is going to indicate the direction of the prevailing planetary wind. Now, at our latitude in America, most of the continental United States of America, that particular prevailing planetary wind is the westerlies. So let's imagine that this is happening at our latitude, but it can happen at any latitude. So here's what happens. You've got air flowing in, just naturally moving the way it moves, according to the prevailing westerlies. And now what happens is that air encounters a mountain range. Now the air is not going to be stopped by that mountain range, and it's not going to go through the mountain range. The air is going to have to go over the mountain range and then back down again and continue on its eastward journey. So what happens? As the air encounters the mountain range, the first thing that's going to happen is the air is going to be forced to rise. Now, again, we know this, that rising causes the air to expand because there's less pressure on the air. That expansion causes what we call adiabatic cooling. So the adiabatic cooling, now the air is getting colder. And of course, what happens then is the cooling causes the water vapor in the air to condense, and we have our condensation, which forms a cloud. And naturally, the next step, what falls from a cloud, you've got your precipitation. So now, the rain is going to fall on the first side of the mountain that the air encounters. This side of the mountain is known as the windward side. See how it was written there on the side of the mountain? So the first side that the air encounters, or that the wind encounters, is the windward side. And that causes a great deal of rain to fall on the windward side. So the windward side of mountain ranges is always going to be more humid and more rainy and more lush than the other side, which is known as the leeward side. So the air is going to sink back down on the leeward side as it continues on its journey. So let's continue this. So now the air begins to sink. That sinking is going to cause, well, the opposite of expansion is going to cause compression. So the air gets compressed. Now when air gets compressed, its temperature goes up. So the air gets warmer, it gets heated up. Now, just imagine if you suddenly make the room hotter, water is going to evaporate. You're going to increase evaporation. So that causes the area here on the leeward side to be much drier because all the moisture has evaporated. And that creates a drying effect in this area right here. So the windward side is the moist side, and the leeward side is the dry side. Now we have a nickname. Some deserts generally tend to form on the leeward side of mountain range. Some of the world's major deserts, Now, the area on that side is referred to as a rain shadow. All right? So in the rain shadow of mountain ranges, we do get some of the world's most impressive deserts, and some of the driest places in the world are in the rain shadows of tall mountain ranges. Now, naturally, the taller the mountain range is, the greater this effect is going to be. So it's time for us to ask ourselves a few questions here about this. So let's take a look at the questions below. So rainfall occurs on which side? Take a minute, pause the video, see what you think. Okay, rainfall occurs on the windward side, where the air is doing what? What's the air doing on the windward side? Pause, answer. Okay, your answer is that's where the air is rising. Now, please complete both for the leeward side. It is dry on the leeward side, where the air is sinking. Okay, so mountain ranges have a profound effect on our climate. They create a very wet side and a very dry side. This is really evident in Washington State out west. Next to the Pacific Ocean here, we have the city of Seattle. And then we have the Cascade Mountain Range, a very tall mountain range. And then on the other side here, the eastern side of the Cascades, we have a city called Spokane. Spokane's in a rather dry place. But if you go to Seattle, Seattle is known for being extremely rainy. And this is exactly the reason why, because it's on the windward side of the Cascade Mountain Range. All right, let's try a few more problems to solidify our knowledge here. Here's an excellent diagram from a past Regents exam. So let's take a look at some of these questions. Question number 1. What is the temperature 2 kilometers up on the windward side of the mountain? And your answer is 10 degrees Celsius. Okay, now let's see you interpret questions 2 and 3. Answer those. Pause the video if you must. Okay, so what's the temperature at the same height on the leeward side? Well, in that case, it's going to be 14 degrees. Now, at which altitude did the air first reach dew point? Well, it's a shame the diagram gives that away right here, because I would have preferred to ask you to figure it out. But you know, the cloud base is where we reach dew point. So that altitude right there is just 1 kilometer. And now, number 4. Which side of the mountain is generally wetter and which side is generally warmer? Please answer those. Pause the video if you must. Let's see how you do. Welcome back. The wetter side would be the windward side, and the warmer side would be the leeward side. All right, pretty easy stuff, right? Okay, so now we understand how mountains affect climate. Mountains actually affect climate in a couple ways. If you're on top of a mountain, you're going to be colder. And they also create a wet side and a dry side. So mountains just make our world more beautiful and interesting. All right, thanks for tuning in. Again, I would like to cite David Mills for the use of these cool diagrams and some of the actually early notes of his that I'm morphing into this. And have a great night.